Okay, yeah, thanks for the intro, Jan. So, achieving state-of-the-art developer experience by combining generics, conditional types, and map types. You will see that this is not a seminar about concise talk titles, but let's make it a little bit more concise. This is basically a deep dive into advanced types in TypeScript. So who am I to talk about advanced TypeScript? I'm Tim. I'm working here at Prisma and I'm using TypeScript for a couple of years now and implementing basically a database driver called Photon.js, and I'm responsible for the TypeScript part of it. So let's go back a little bit in history, or very recent history actually, which is January of this year. We knew that we wanted to do the next version of Prisma, and we knew that mapping the data based on what you're actually looking for, based on the query, to your programming language, it's a hard problem, and there are not really great solutions out there. And let's assume we have a schema like this. So with Prisma, you basically define a schema in a schema.prisma file. So we say in this case we have a model user. A user has posts, and a post has certain fields like a title, and fields can be optional. And the question is now, how can we query this data? How can we map this to TypeScript? And so we were thinking a little bit about Dream APIs, how we would like things to look like. And one Dream API was this, that we basically say, I just say Photon, find one, give me this particular user back, and I have the user type. But this is simple. You will see these kind of examples on all kinds of ORMs. But what is a little bit more tricky is if we say we're only interested in the ID. And what would be awesome, that is the Dream API here, is that it would now say we only get back the ID in TypeScript, so we have type-safe access. Or we would say we also want the email. So that basically TypeScript would dynamically generate the correct types for us without any type generation. And why we thought this could work is because since TypeScript 2.8, there's a feature called conditional types. So you can basically say, when I have a specific input in my function, I want to have specific return type with these conditional types. You can define like an if-else on a type level. And after about 1 week of research, the answer was no, it doesn't work. After another week of research, the answer was, it works. Because why was that so hard to find out? Because there are no examples about this out there. And we will dive into some more complex TypeScript concepts. And this is like some bigger nested TypeScript statement here. And my goal for today is that you will understand the statement at the end of the talk, and that you are able to actually use this stuff, these advanced types. I call them advanced because in the TypeScript docs they're listed as advanced. I hope that you will then be able to use that also in your project and see how this stuff can be useful. So in order to really get the value of this, let's start with the demo. Oftentimes people end the talk with a demo after they motivated why the tool is awesome. We do it the other way around. We say the tool is awesome, and then we reverse engineer. How can we build such a tool? So in this case, we, for example, say, Photon, can you see that? Yeah. In this case, we say, Photon, please give us the users. And we are only selecting the ID and the name. So we see in the resulting output type, we also only get the ID and the name. If we now say that we're not interested in the name anymore, we see that actually TypeScript is toggling a type error here, and it says name is not a thing anymore because we're now only getting back the ID. However, scalars are simple, and what we're actually interested in is querying relations when we have a relational database under the hood. And we can say now here the posts, we also want them, and for the posts we're, for example, interested in the ID and the title. We could also query for something else. Let's say we're also interested in the content. So we say content true, and we also get the content of the post. So like this, we now have type-safe access to our data. And as you see, we have some kind of query language in TypeScript. We're using TypeScript as the query language to get type-safe access to our data. So this is basically what we want, and And by the way, we should also be able to run this just to see that it's working. Yeah. So we get exactly also in JavaScript then obviously back what we're defining here. So depending on how this query object looks like. And as we see, we have this select object here, which is defining the shape of the return type. Let's go back. Yeah. So, and in order to do this, what we're pretty much doing here today is type level programming. And what that means is that if you have a concept like a variable in your normal runtime and how you're programming, we also have an equivalent on the type system level. And this is not 100% whatever proof to people could find flaws in this, but if you want to see if you want to have a simple mental model here, you could say that variables are roughly achieved with generics in a type system. We can have loops in the type system. We will see mapped types that are achieving that. We can have something that is enumerable, something that we can loop through, which is a union type in our case. We can have if-else statements in a type system in TypeScript, which are conditional types. And we can basically perform an object.keys statement on a type, and that is just the key-off keyword that many people probably already saw. So, and what we're basically doing now is we're the same as in a math lecture. We're starting with the basic axioms. And step by step, we're building up these more complex concepts. For example, what I just showed you, the generics are still a fairly simple thing, but then later, I would say the most complex concepts here really are map types and conditional types. So let's start with the most simple atomic concept here, which is a string literal. So what we can say that we just have a general string. And the second variable here is str is a string. We typecast this now on a string, and that's it. But we can also say that it has to be a particular string, in this case a hello. And why should this even be useful? This doesn't look very useful like this. However, as soon as you're able to do a union over these types, it gets useful. So we can now have a union. And a union, this is a type that's a term that comes from set theory. So you can see this basically now as a set. So the string literal union, which is nothing else than just two strings, this is now a set. And we can now say that this variable hello, it's a correct instantiation of that set because hello is part of the set. And the same for world. World is part of the set. And so where are these string literal union types now interesting for us for the key-off statement? So let's say we have a type user like so, and we now want to do this type level object.keys operation on it. And what we can just do, we can just say key-off user, and we will get back again a string literal union. I will from now on just say we get the keys, because string literal union is a bit, it's a weird word. And so this is an important ingredient for our nice soup that we're cooking here, which is this beautiful API. So we now have, we have string literals, we have unions, we have the key-off statement. Let's look into generics. You can think of generics, there are for sure 1,000 definitions, but you can think of them as a type parameter to your function. So if I now, let's say I have a function that takes something and it makes an array out of it. By the way, why is this type parameter interesting? So let's say generics wouldn't exist, then I would now have to define this concretely for strings if I would like to turn strings into an array. And if we wouldn't have generics, we would also have to do this for numbers and so on. And in order to save this effort, we obviously want to have a generic, how the term says generic, we want to have a generic definition. And this type parameter helps us here because we don't care what kind of type that is. We just say this is, we just turn it into an array. And examples here are we want to make 7 to an array, so we just have an array of 7. So we get an array of number, or if we pass in a string, we get an array of strings. So very basic concept, and note the type parameter is very important here. And what you see, this is called t. So this is basically now a variable in our type system, and we will later use this a lot in order to calculate more complex types. Now in TypeScript 2.8, this concept of the conditional types have been introduced, and the idea is basically, so again we have our t here. The idea is basically that we say if t is a u, then please return x. If it's not a u, return y. So we can use these conditional types now on a return type of a function. And to make this a little bit more real world, let's actually look into an example. So let's say we have a function. This is not pretty formatted, but we have a function x. And t can either be hello or world. If it's concretely, if we say t extends hello, and extends in this case, you can just think of it as equal. It's the equal sign, the triple equal probably in JavaScript on a type level. So we say if t is hello, then return mellow. Otherwise return I don't know that word. So that's a simple ternary expression that we have here. It's the same as if in JavaScript we would say question mark and colon. So it's a if-else statement that we have here on this type level now. And you can also have something that is a little bit more complex. We could say let's cook a soup, and if we have a potato here, if t is a potato, then our soup will be a potato soup. If t is a pumpkin, then we want to make a pumpkin soup out of it. And now we see this keyword called never here. And never is basically, in TypeScript it says, it's basically type error. So that means it's not a correct type, it's nothing, it's not a thing. And this never type will later also be used a lot. So now let's actually implement this query that we just saw earlier in the Photon API. And we may, for example, say we want to implement the find many user query. And we saw earlier that with a generic type parameter, you can pass it in like this. You can put it there in front of the function definition. And what we do now, additionally, we put in a base constraint. So we say that t shouldn't only be any t. Obviously, we want type safety. People shouldn't just provide any object there. We say t concretely has to extend user args. So now we just thought about it. Okay, we're implementing this API. We add this t extends user args, and we think we're done with our job. We can move on to the return type of the function. It's not that simple. The problem is, if we are now thinking about hierarchy and inheritance, a t, so as all properties of user args are optional, first of all, an empty object would be correctly inherit from user args, but also an object that is empty, plus it has some other properties on it. That's valid in type inheritance. So what happens now that users can provide any arbitrary field here, for example, random prop, and it would be valid. And this obviously is not what we want. What we want is that we're only allowing the properties that make sense. So how do we solve this now? Because we somehow need to access this t thing, but this extends is not good enough. And if we would now not access the t anymore, but just directly say this has to be user args, this also doesn't work. So you could now say, okay, talk over, sorry, it doesn't work. But we have another trick which we can use, and that is this. In your argument definition of your function, you can again have basically a typed, parameterized type. In our case, we say we, for example, use a utility type. I will later show how it works, called subset. And we are now again narrowing down what t can be by this trick here. So we say not only does it have to extend user args, so in case that user args, for example, would have a required field, it needs to have that required field, but also it must not have more. than that. And now we will get a proper type error. But now, how does this subset type work? It looks like some magic here. And in order to understand subset, we go into the next concept, which are map types. As I said earlier, map types are a little bit like a loop in TypeScript. And let me explain this map type here called pig. Pig is shipped in TypeScript in the standard lib. So if you're, for example, having ES5 as lib enabled, pig is just a global type you can use. And how does this one work? So what they basically do, they basically say k equals key of t. So this is pretty much again an equal sign. In this case, not the triple equal, but a 1 equal sign. So it's basically a variable assignment. So they take something out of t, in this case the key of, which we saw earlier. In the end, it's really just taking the keys of t and assign them to k. And what we say now is that similar to how we would define object in JavaScript, we define an object type here, and we have this in statement here. And the in statement basically says we are now looping through all the keys of t, and in our loop, our variable that we are getting the key, that we're assigning the key to in that moment, that variable is called p for property. So we can now loop through all keys, and we're packing out basically the t here. And obviously, k can also be overwritten, and you could say I just have a subset of the keys of t, and so you can now with this pick out certain properties of that type, the ones that you want to use. So this is a standard mapped type that you have in the standard lib, and but we're interested in subset. So how does subset work? This one is not in the standard lib, but how does it work? So the idea is basically that we are again looping through the keys of t, and we say that if this particular key is also in u, then pick it out. Otherwise, put never on it. And never again on a type system level means throw it away or filter. And if we would now write a similar code like this in JavaScript, this would mean we're basically performing a .filter operation. And the equivalent of returning false in this in the filter callback is us having the never in here. So like this, we can now filter out the subset of a type. We say, give me only the keys of t that are also in u. So that's basically the idea here. And here's a quick example. Again, we do the key off, and but I think I already explained this, how the key off works. So now we get the type error, and we're done with the arguments. That's nice. And now comes the hard part, actually, which is return types. Return types. So now we will actually use conditional types, and we saw earlier in the API that if we are not providing the select keyword, we want to have a default behavior. We just want the user. And that basically means what we're saying here now, select extends key of t. In other words, does the property select occur in this type? If yes, we'll do some magic. We are diving into that later. If select is not there, we don't care. Then we always know it will just be a user, and we just return the user. And the whole complexity now comes in this magic part. And the idea is that, okay, we know it will definitely always be a promise of an array, because we know we first need to fetch the data from the database, so it is a promise, it's an array. And in there we now have a type. And you can just think of this type as a function, because it has input and it has output. So you could just say it's basically a function on the type system level. And this function will now help us to extract based on this what is defined in select. Concretely, the type of this is user select. And this function will now help us to extract a correct return type based on what has been provided here in this user select. So let's dive into how this type or utility type works. So we say, as we said earlier, the type parameter here needs to correctly extend a user select, otherwise we cannot work with this. And what we're doing again here is a map type. We're looping through something. And what are we looping through? We have something here called get through the keys. And what we are only interested in, and what does this mean, get through the keys? Let me show you a quick example. So what we need to accomplish now is that if, for example, name is false, it will not end up in the result. If name is true, we want to have it in the result. And how can we now accomplish that on a type system level? We use a utility function or utility type called get through the keys. And how is get through the keys defined? What we do, again, we loop through the keys. And what we do now is we say if it's false, put never on it, otherwise just return the key. And in this last statement here, we are just basically filtering out and making sure that we only filter everything that is actually a key of T. So we now have this utility function defined, get through the keys. And this is an example. So if we would have an X where, for example, B would be false, then B would just be filtered out. And again, we have a union of string literals, but in the end, we just filter out the keys where the values have true types. And now this looks already a little bit like JavaScript again, but we are really just talking about a concrete type called true. You cannot only have a Boolean as a type, but you can also have a type called true or a type called false. These are concrete, valid types. So now back to our map type. We have our get through the keys function here. And so what are we doing now? We say that if this property extends key of user, in other words, if this property occurs in user. And what we saw earlier is that the user type, these are just the scalars. In case I haven't shown it, just to make sure. So if we have type user here, we just have the scalars. In this case, ID, email, name. And we're basically saying, if this is part of this type, then just pick it out of that type and we're done. However, if it's not part of this simple scalar types, then we have to look into some more recursion here. Concretely, we know a user can have posts. So if concretely this property is called posts, again, the extends is nothing else as a triple equal sign. If that property equals posts, then let's go into the next function. And this next function would work exactly the same for the post type as we have for the user type. So it would again loop through all the properties, check is it scalar or not. If not, then it's a relation, and we again need to go into more recursion here. And again, to understand how does that actually look like when we use this, we are now talking about this here. So for the scalars, we just have a Boolean true or false, but for posts, we now again have a select object, and then you can basically go as deep as you want. Okay, so let's go back to the original definition that we had here. So we now dove into how this user get select payload utility type works, and we basically just implemented a pretty nice API with a type-safe database access. So this was a lot, and I hope I didn't lose too many of you. I know this was a lot to cover in the short amount of time. I want to recap a bit what we just saw. So we saw that the conditional types help us to narrow down which concrete type this is in our return definition. We have seen that the map types are basically the loops of TypeScript. We saw basic set theory. We could, for example, use a subset of properties and so on. So in the end, this is always just set theory. And we could see that we can just define these map types and conditional types arbitrarily deep. Now you may wonder, okay, how can I use this stuff in my project? You may not want to implement this style of API, but still there are very interesting advanced types out there right now. So you can, for example, extract the return type of a function. You can pack out if a type is wrapped in a promise, you can put this promise away basically and get that type, or you can also omit certain keys or certain properties from an object. So these are some nice utility types. All of them are again in the standard library of TypeScript. They are globally available. You can just use them without import. Good. So the goal was that you get a rough overview about these advanced types, and I hope that you will find nice use cases for them in your project to be more productive and have a nice developer experience. Thanks. Questions? Yes, please.
Yeah, you were defining there a type return that defines the user selected, and if there was not the select attribute, you return the posts. I get the example, but is that actually something that you use? Because it looks like there's no separation of concern. You get a payload that comes with a user or with a list of posts.
So in this case, what we're basically saying is if the posts property is there, then we know we have to query for it. What we also know is that we already did the promise resolving earlier, so we know it's already an array. So we don't even have to care about promise anymore. So because we already entered through this type here, so we already have promise array wrapped around this whole thing. And now we're going deeper in there, and there we know that we will query this anyways, and we can get the posts. Yeah. So, but to be fair, this is a simplified version of what we have. We are allowing some more stuff, and select is just one syntax. We also have an include syntax, but it doesn't matter. This stuff also works. You can basically just concatenate the slides and try it out in whatever editor. Yeah. Please.
So basically you're defining logic inside the type system, right?
Yes.
Can you actually, because it's not trivial, right? Can you unit test this in the fact that you're not going to break someone else's code?
I mean, yes, because, so first of all, what happened in the beginning of the year is that TypeScript did an update and suddenly this broke. So now we have Photon code actually as unit tests in the official TypeScript code base, which is nice. But actually, yes, you need unit tests. But I mean, you can really just define your type statements, run the TypeScript compiler, the programmatic API of it, for example. So we use that together with Jest, and we just see is it compiling, basically. So, yeah.
And just sorry, one more question is that how do you make sure that actually this type declaration are in sync with the implementation? Because I see that there's a few magic happening there, right?
That's a good question. What I also didn't mention is that to make this happen, we need code generation. So there are a couple of ORMs out there which are completely defined based on a generic definition. So you really just define your user type, and based on that, everything is calculated. That's not the case here. Especially if you see this select payload type, that needs code generation. So there is no way around it. With the current TypeScript today, you need code generation. So that means how it concretely works is that your source of truth is this schema Prisma file. And as soon as you edit it, we will regenerate the code. Yeah.
Don't you have issues with recursive, like if a user has friends who are also users? Don't you have issues with that?
No. So in our, that's a good question, and we can also I can show you an example because we have a recursive type here already. So you can say we have an author, and an author again has posts, and so on, and you can select them. So that is what I meant with recursive. Okay, the name is not there. With a deeply nested recursion on some slide, it is possible to have that indefinitely. Yeah. So I mean, it's a question if it makes sense to do this particular query, but you could. Yeah. Okay. Good.